So again, I'm going to ask for today. I know sometimes we talk during Ready First, but I'm going to have today you just try it independently. And I know you might finish quickly and then just be sitting there, but I'm going to ask that you keep your voices off while the people around you might still be finishing, so that we can make sure we get to all of the review today that we want to do for next week. Alright, let me quickly take attendance. Y'all, make sure in the next minute you have an answer to this question. Picked, pretending it's your quiz next week. Gio,
Here.
Samuel,
Here.
Pedro, Laisha, Johan,
Here.
Pedro,
Here.
Kaylin,
Here.
Carlos,
Here.
Catherine,
Here.
Caitlin, Levy,
Here.
She,
Here.
Jason, Jeremiah,
Here.
Cindy,
Here.
Jennifer,
Here.
Angela,
Here.
Brandon,
Here.
Michelle,
Here.
Osi, Omar,
Here.
Christian, Diana, Samantha,
Here.
Fatima, Natalie, Emilio, Javier, Edgar,
Here.
Samantha. Just the front for now, because the back we're going to do as we leave. Okay, let's go ahead and get started. Today is Friday, so we will be raffling off, and today's raffle is not a surprise like last week. Today's raffle is, last night I made some cookies. So if you like chocolate chip cookies, then today, if you do not like chocolate chip cookies, I'm sorry, because that's the only prize I have today. But that means at the end of class, there will be, I believe I made enough so that I have at least 5 for every class. So 5 winners at the end. I'll draw 5 tickets, and those people on their way out can grab one and enjoy. Okay? And if you win and you don't like chocolate chip cookies, you can give it to your neighbor. Okay. So here we go. If we take a look at transformations, first question, I'm going to kind of break this up. I don't want just the answer yet. Who can tell me, raise your hand, don't shout out, what is the parent function called of like this graph here? Like if I ask for, this is the graph, what is the parent function before the transformation? Jeremiah, what is it? The absolute value function. Very nice. Come bring you a stamp and a ticket. So Laisha, if we take the absolute value function, which one do you think is our transformation of the absolute value function?
You mean the answers?
Yeah.
Okay, I put H.
H, she says, and that is correct. Where's my, gotta get my clicker going on here. That is correct. So let's talk about Y so that I can get some more people points on the board. Not that we're cracking, we're just doing. Who can explain why as I bring them tickets and everyone else's voice is off and is listening to why? At least you get to pick who around the crowd is going to get to do this one. Take a pick.
I pick Omar.
Omar. Keep your stamp too.
So, the reason I got H as well is because the absolute value x is at the origin, but if you add -4, x minus 4 is going to move left to right, and since it's negative, it's going to move to the right. So you go to the +4 because math is weird. And then 3/2 is the rise over run. That's the slope of where the line is going to go. So it's going to rise up 3/2, and as you can see, the first point that it hits is rise up 3
So
and
it goes
2.
over 2, because I'm really shaky, but look at this. 2. Okay, I don't know. I mean, I'm not. It's just really far away, so it looks like it. But cool. So that's how we figured out that 3/2. So I would agree. The first kind of like time I did this, from the beginning, I eliminated these two because of the +4. Okay. But then I was like, oh man, I gotta figure out this like 3/2, 2/3, I don't know which of these. So that's one way you can think about it. Another way, I still also love kind of like I said the other day, like just looking at the points, plotting points, things like that. So if you pick a point on this graph, like this is 6, 0. If this is my equation, I should be able to plug in 6 And what should I get?
0.
0. So let's check really quickly. 6 minus 4 is 2 times 3 halves minus 3. The 2's will cancel. 3 minus 3 is 0. So that works. This one you would get not 0, you'd get something else. Okay? Cool? So 2 ways for us to like kind of maybe test that last part. Okay. So hopefully you feel okay about transformations. If not, use that as an indication to look over all of the transformations that we talked about that I have right here on my green poster. So, reminders, and let's talk about grades for a second. Seniors, I don't know if you know this, but juniors, I know that Shukir mentioned in our family gathering, the next Friday is the end of A1, which is super weird because of the 2 weeks we lost. We've really only had the first 2 weeks of school, and then we were back this week, and then next week, and that's like 4 weeks, plus the 2 were gone. There we go, there's our 6 weeks. So, as a result, we have not had as many grades as usual, so I want to talk a little bit about like what I'm keeping the same, what's changing, just kind of like where we're at with that. While I'm doing that, I'm going to have someone very silently that I can trust to do this silently pass out for us. I managed to get my review printed, which shows all the topics we have basically learned in this unit that could be on the quiz or test, and like the helpful things about them that maybe I have on my poster or like some other things I added on. That when you look at a section, if you're like, ooh, shoot, I need to know more about that, then you can go look in your notes, like the more detailed version, okay? Johan, can you do it nice silently? Just give enough to every table of the review. Everyone else, keep watching up here. Let's talk about on your syllabus at the beginning of the year one more time where your grades come from, okay? Quizzes and unit exams are 90% of your grade. This is why A1 this year is super weird, because that means 90% of your grade is coming next week, because your quiz and your test is next week. Kind of scary, but I just want to like put that on your radar so you're not just like, oh well, I'll get it next time, I'll just get away with this quiz on Monday and whatever. Like this is an important quiz or test more than ever. They're all important, but more than ever because this is 90% of your grade, and this A1 do not have time to fit Unit 2 into A1, okay? Second, 5% of your grade comes from problem sets. 5% comes from participation. So let's talk about that. Problem sets. We ended up not having time for 4 problem sets. We ended up having time for 3. And your third one is due next week. Right now, you should know, based off of me passing back the first 2, kind of where you're at, what your average is on problem sets from either checking online, or if you don't have access, you can just average the 2 numbers I've given to you. And then be thinking about what you think, like your goal for problem set 3, to make your average for your problem sets wherever you want that to be. For participation, I know we've been using our tracker, and some of us have been participating a ton and have a lot, and some of us might be like holding out for the end, but the end is like here. So next week, even though A1 ends on Friday, next week is like testing. Like Monday is a quiz, Wednesday and Thursday we're going to be testing. So that leaves today and Tuesday as the only other days to collect participation stamps. Okay? Now I understand that we lost 2 weeks. Okay? So I'm going to account for that by, I was thinking about collecting them today, but I'm actually going to, because I want to stamp today and I want to stamp Tuesday, I'm going to collect these when you are taking your unit exam. So like Wednesday, Thursday, I'll collect these. And what I'm going to do is basically just make sure that my average for y'all on these is still where I want it to be at, which is like around like an 8. Like I want it to be like around an 8. So if all of us are like at a 7 or whatever, then I will cushion and I'll curve appropriately to where I feel like we're at a fair place. What that does not mean is that if you have right now like 1 stamp that you're like safe and you're going to get a 10 on participation, because it's not going to curve you all the way up from the bottom to like the top, right? So I know that's not a very concrete example of like how much am I curving by, because it kind of depends on how we like compare to our peers in terms of making sure that we like average out somewhere in between, okay? So I'm gonna give you 2 more days to like give it your best effort to get lots of stamps. Today I'm gonna be definitely not just giving tickets, I'm gonna give you a ticket and a stamp like the people I already gave them to. And rack up as many as you want, knowing that there's a little bit of a cushion there, okay? Next up, quizzes and unit exams are gonna come from the quiz on Monday, and the exam, this is wrong, I just keep forgetting to change it, on Wednesday, Thursday, okay? So if you're curious about like where you stand or how to calculate your grade or this, that, or the other, these are percentages, so you should be able to calculate at the end of like next week where you're at when you get things back graded. So if you want to like, I'm going to show you one scenario here. Let's say problem set 1, you had like a 9, problem set 2, you were like, I got like a 7 on that one. That would mean right now 9 and a 7, if you average those, that would be like right now your average is an 8 for problem sets. And maybe you think like I'll do about the same on problem set 3, maybe I'm going to land at about an 8, okay? For participation, maybe you're looking at your tracker and like I see Fedra right now is at a 9, or maybe you're a little bit under that, but you think with the cushion you might be at about a 9, okay? Yeah, there's a lot of people that have, I got people that have 10s already. I know. What's the Alright, if we have that, then our quizzes and unit exam, you could give an estimate. Maybe let's run the scenario of if you just like are at that passing 7 when you average your quizzes and unit exam, you see where this person lands in the grade book, okay? If we have 5%, then you can take an 80 and multiply it times 5%, right? 80 times 0.05. If you're at a 9, that's a 90. 5%, multiply it times 0.05. If you're saying, like, okay, let's say I'm at like just that passing 7, 70 times 90% would be multiplying times 0.9. If you do this math, this gives you 4 grade points, this gives you 4.5, this gives you 63. So notice a 70 on these quizzes and tests, if you had like ignored the problem sets and the participation tracker, like assuming those would be zeros, like you would not be passing if those were zeros and you pass right at a 70 on the quiz and tests. These would bump you down, right? If though you've got like an 8 and 9, you're bumping along with your participation and your problem sets, that's enough to get you above your 70 to a 71.5. So notice wherever you land for your 70, if it's a 70, it's going to bump you up and down. Imagine you're like maybe that person that you're like, I'm picturing myself as more of a B or A student, and I'm on that line of an 8 or a 9. These two things are either going to bump down or bump up, okay? Problem sets, if you're putting in lots of time coming ahead of time to me, like early in the week, like day by day, to ask me questions and stuff, like there are people that get 10s on every problem set because they're just like, it's like their thing that they want as like a solid cushion every time, and then they tend to do better on these too because it means they have like really solid practice always on their problem sets, okay? So A1 we're going to learn, we're going to be okay, but I just want to give, I don't want this to be a surprise next week, right? So like better now than never, and that prepares you for today in class. Super focused when we're going through some review problems, and over the weekend making sure you're ready to go for these assessments. Okay? I got a few people staying after with me today after school to work on some stuff too, so if you have questions, you can come on by. Okay? So you got your review, you've got the lowdown on grades. Let's go ahead and pick up where we left off yesterday and make sure we feel really good about inverse functions. So go ahead and grab your notes and flip to that very back page. We're practicing the last few problems on that page, and then I've got some extra practice problems depending on where we land. Yeah. You don't even have to flip through, like if you just turn it to the back, it should be where the staple was, like the very back page. Okay. Yesterday, we learned how to determine, first, if there's an inverse function, okay? Then we learned the steps to find the inverse function algebraically. And then we also talked about how a lot of times inverse functions have a domain restriction because of some funky things that happen with our graph. And we made sure our answer was nice and pretty and finalized with that, okay? So of these 3 examples, I believe in this class we have not talked about any, correct?
Yes.
Okay. So starting with this first one right here. Starting with this first one, can someone remind me how, from the beginning, we even tell if there's going to be an inverse function, or if we're done, we just say no inverse function? Javier?
With a horizontal.
Horizontal line test, and does this one, someone else, does this one pass the horizontal line test? Yes or no? She, what do you think? No? Why not? Where are you saying that there might be an issue? Show me, I'm gonna come over here and give you some. Oh, you think yes?
Yeah.
What do y'all think? Thumbs up or thumbs down? Yes or no? Yes, I see some other thumbs up. What do you think, Felicia? Where do you think there might be an issue? All right.
I think there might be an issue in the negative part because it goes like this.
Yeah, like this part?
Yeah.
I've had a couple people that have been asking me, like, they're like, I think when I draw a horizontal line, like, it's flat right there. In general, I know it's kind of hard to tell, but if it's flat, I'll make it super obvious that it's like a ruler, like straight line. This is, I know, looks very straight, but it's very flat. But it's just, it slows down, but it's just barely still increasing. So if you zoomed in enough and I draw a perfect straight line, it will still only go through one spot. So, you are correct. I understand that this is kind of hard to tell, but it's just flat. It's not constant. Perfect flat. Okay? Okay. So this is going to be yes. So now we talk about finding the inverse. Okay? What was our key idea of like next step? What do we have to do with this function to change things around to find like the opposite or find the inverse? Anyone remember like what we take this thing, we do what, Rhiannon?
Do we switch the x and the y?
Perfect. So think about this as a y and this is x, and if we switch them, we would have x equals negative 16 plus y cubed. Now we try to, what then you switch them? Now we try to solve for y. So I want to see if y'all feel comfortable with this or not. So I'm going to give you a second, like 30 seconds, then we'll come back together, or maybe like a minute. Talk to your neighbors, go through the first few steps, see if you know what to do to solve for y. And if you get stuck, that's okay, because we're going to come back in a second and talk about it. Okay, so really quickly, try on your own while I bring these stamps and things to people. What would you do? So what do you do now when they give a cube? Talk to your neighbors, see if they know what to do about a cube. Close. Don't worry about it. It could be a square root, so that would be for a square. It's going to be slightly different. Who did I have? I had Shannon. I'm looking for your hand.
It's always up.
Okay, I'll call on you the next one.
I got another one.
The last few I just skipped over, let Raina and I end up using. Because I know you're concerned about your participation point. I'm sorry. I'm sorry. I'm going to make an effort today and tomorrow. Do you have another one? Oh, you're flat. Okay. Bring it back, bring it back. Okay, what do we do first? What do we do first? What do we do first? Add 16 to the other side. X plus 16 equals y cubed. And this is where I saw some people then that were like, I'm not sure what to do next. So let's talk about how we get rid of that cube. I see this table in the back. Seems like they're doing okay. And I'm feeling the pressure now because people are like, you need to call on me. So Cindy, you get to pick. I'm taking the pressure off myself. Pick who over there is going to get the next one.
Sam.
Thank you.
Go ahead. Friends helping friends. Love it. Go ahead.
You do the cube root on the
Good.
side?
So I had a couple people that asked me, can I do this? That would undo, listen up, that would undo if this was a 2, like a square. So what we do is similar. We're going to do the cube root because a cube root, it just is a square, it's similar to a square root, but it undoes things that are cubed, so it has a little 3 right there. And that will cancel this. So we have y equals the cube root of x plus 16. Who can tell me, I cannot leave it like that, so who can tell me how I make sure that I am mathematically accurate, and how do I write my final answer? I know Gio, you said I haven't called on you either, so Gio, what I do?
We have to like -1x equals
Cool, and we say this as f inverse. Cool? F inverse of x is equal to the cube root of x plus 16. Okay, now to find our domain, to see if there's any domain restrictions, we also learned this yesterday. Who in here, I'm just like giving a million things out, who in here can tell me how we find the domain of an inverse function? Fatima? Find the range of this original function. Take a look at that original function. Are there any y values that are missing, that there's like a horizontal asymptote or a hole or anything like that? Or am I good the whole time? Good the whole time. Like there's no breaks in my graph. So all the way from -infinity to infinity, this one actually will not have any like restrictions on the domain, but we checked. Okay? Jeremiah? No? Just checking something? You checking the cubic? You're good? Okay. Okay. Next up. So this one is very doable, but I wanted to kind of like just review all the steps with us one more time. This next one, I would release you to just go do this next one, but this next one, algebraically, is sort of different, where we're going to run into some issues, so we're going to talk through, but you should be able to get it set up. So I'm going to give you, like, again, like 45 seconds, a lot of like back and forth today, like 45 seconds independently right now. I want you to start by switching your x and y's and just taking a look at it. So I'll give you a second to switch your x and y's and get started. Oh, first, like, we had to check. And what did you say, Caitlin? Yeah, it only passes through like one spot, and so we're good. So we can find the inverse. We had to check that, so I ignored that. We checked. Cool. So go ahead, switch your x and y, and let's see. Good question. So Rand's like, this one's different. There are 2 x's, which means we will switch and we will have x equals y plus 7 over y. So everyone go ahead and make sure that's what you wrote down. If not, we write it. So let's talk about this one. Okay. Very good. Okay. Now this is strange because unlike the other one, we have 2 y's and we want y equals, and so algebraically I've noticed this is like a little more challenging for people because we're not sure like how to get the y's, where we want to get them. So let's follow our gut instinct. I've noticed today and yesterday, anyone that solved this problem, most people had the right idea of what to do first. So just trust yourself, raise your hand, and it's okay if you're incorrect, but raise your hand if you can give it a shot at like what you think maybe you could try to do first. What would you maybe want to try to do first, Michelle?
Multiplying the y.
Multiply times y, correct. So let's try to get our y like off of the bottom at least by multiplying times y on both sides. So now I have yx or xy, that's the same thing, equals y plus 7. Looks a little cleaner. Maybe we're getting close. Okay. We still have a y over here and a y over there, and we want a y on one side and everything else on the other side. So this is a little bit strange, and this is where we're going to have to do some creative algebra here to get our y by itself. Any ideas, and then I'll kind of model how I would do this, but anyone have an idea of what they want to try to do? Laisha, what would you do?
Okay, so what I was thinking is maybe that we would add the 7, and then we would switch the x to the other side, so it would be like y squared or something.
Okay, so I like where she's going. Don't write yet. Don't write yet. If we subtract the 7, let me just show you what we'd get, like down here. And then she says, let's try to move over the x. The issue is, since the x is like in between multiplied times this y and with the subtract 7, I can't just remove the x and pull him like over, or just remove the y and pull the y over here by itself. So we're going to kind of run into some issues. It doesn't mean you can't subtract 7 over, but we're not as easy as then just moving over the y and saying like we're done. I'll take like one more and then I'm going to kind of model where I would head with this, but I love the ideas. Sometimes we just have to like try things out and see what happens. Rhiannon, what would you do?
Could we subtract the y?
Okay, let's try that. So if I subtract, that's what I'm going to do, and I'll show you why. If I subtract the y over, I like this because at least my y's are closer together. They're on one side, and my thing that like doesn't have a y is on the other side. Okay? Did I give you a ticket? And we bring you a ticket. Okay. So now I have y's over here, and I have the 7 over here. This is going to be a lot of times our goal, and I'll go ahead and tell you why now. The cool kind of algebra trick that we can do to get y by itself is once I have terms that have only y in it, I can say that that is a common factor. Y is like a common number that I can pull out front, like I can do the oppositive distribution and I can pull it out front and see what's left for every term. So let's talk about this, and then you'll learn this as, this might seem like, how would I know to do that? But like you'll see it happens a lot and you'll just get used to like putting your y's together and factoring out a y. So over here, what would be left if I pulled out a y? The only thing left in this term is x. And then if I pull out this y, it seems like nothing's left there. That means it's like a -1, because this would be yx minus y, right? Cool? Yx minus y equals 7. My y, yes, is by itself, as in like separated. It's still got all this stuff, but it's one y, not like y up here and y down here. That's the goal, okay? And if this is being multiplied, to move it over to the side, I can just divide by this entire thing to cancel it, as long as I divide on both sides like this. And that will cancel, and I just have y equals 7 over x minus 1. So we end up with a fraction looking thing like that. That's just a little different. Yep.
So that one, now would we write the inverse of that one too?
Perfect. So we don't want to leave it as y. So we can say f inverse of x equals 7 over x minus 1. Okay? I forgot you? Okay. Okay. For this one, I'm going to give you the original. You'll notice if you started your problem set, there's some that I gave the original. I gave the original domain and range. So who can tell me what would be our domain restriction on this new function? I'm like trying to think and keep talking for the sake of time. What would be our domain restriction if looking at this function I tell you that my original domain and range was this? Cindy? The range. So now we can just write down that your domain is our old range, -infinity to 1, union 1 to infinity. And you'll see on your problem set, like I just mentioned, on the 2 inverse problems, I believe on the back, there's domain and range written for the function, so you find the inverse and then it's pretty easy to write your restriction. Okay? Alright, so these problems are kind of like strange. So hopefully we're gonna get to a lot more examples where you can like try it out on your own and you're gonna have an exit ticket where you're gonna try it too. One last one right here. Before we jump into any algebra, taking a look at this. Yes or no, raise your hand, does this pass the horizontal line test? Do we have an inverse function, Javier? No, it doesn't pass. So you can just, you're done with this problem, you write no inverse function. Cool? Okay. No inverse function coming. Okay. On the bottom of your notes, checking what time we're in here. 42, sweet. Yeah, it's a weird day. That's why I kind of. You're like, woo, we got a lot of time. Oh, good, you got him. Okay, so keep me on track. If you take a look right here. Eyes back up here. If you look up here, we are going to kind of close out our notes by reconnecting back one more time to making sure we feel good about the graph of inverse and like matching it. And we're going to come to your matching problem in a second, but I'm going to show this as an example and then you're going to do that one. And then I have some other practice problems for you to just get really good at like that weird stuff we just did with multiplying and pulling out the y and all of that. So, when we have the graph of a function and the graph of an inverse, if I have the point x, y on my function, what did we say is true about the point on the inverse? If I have x, y on my function, what do I have on my inverse function? Christian? yx, right? Perfect. So I would have here, for example, this is not in yours, you're about to do one on your paper. If I have 0, 0, then my inverse function should have flipped, but still 0, 0. Does this one, or this one have 0, 0?
Yeah.
Yes.
A, B, or C?
A.
Y'all are like, yes, it is there. A. A has it. Everyone else, if we could turn off the side conversations, that would be lovely. If I look at this next one, I'm modeling this, then you're going to go do one. This one has -1, 1, so it should have 1, -1. Let's check this one. I heard you. Great job, Emilio. Okay, and then last one would have B. This point, if we switch them, will be this point. You can check any point, but let me give you your Alright, you guys do the one on the bottom of your paper. Match them. Same thing, match the bottom ones on your paper. Looks like this. Match them. Five seconds. Raise your hand. Oh, Emilio's first. Raise your hand if you got it. Emilio's got it. Everyone else? I'm going to try to get y'all to as many practice problems as we can, but that means I need you to turn off your conversation. So Edgar as a peer, Jeremiah as a peer. Thank you. Emilio, what order did you get?
2, 3, 1.
2. This one was graph 3. This one was graph 1. I know this one was a little more obvious because they all look very different from each other, but you could pick individual points again and get all of them matched up. Okay. Next up. You are done with the problems in your notes. So what we are going to do now, where did they go? Here. What we are going to do now, still waiting. I put just 3 more inverse problems. The first one has one of those fractions with the top and the bottom. Very kind of similar to what we just modeled, the weird one with the y and the y. so that you can try with your neighbors to see if you're able to algebraically like replicate what we just did, or if you still are like, I can't do this on my own, and we can still model it and talk about it again. Okay? So I'm gonna pass this out. Your task immediately when you get this is to jump straight in to number 1. I want you to try to algebraically find the inverse, and for the sake of right now, find the inverse, and then I did not give you a graph, so I'm going to ask you to not worry about the domain. I want you to just worry about the algebra right now. I know that's not what I usually tell you to do. Usually you have to write the domain, but right now just do the algebra since I don't have the graph for you. This first one right here.
We have to sketch the graph.
No. No. So for this one, all you're doing is worrying about the algebra of replacing your x's and your y's and seeing if you can replicate what we did with your x's and y's. This is good. So when you multiplied it, you have to be careful. Let's go back before you do the 4. When you multiplied it, you multiplied this whole thing. Now you come over here, which means your x is not just x, y, it's x and this whole thing, so you have to distribute it. So you have 5x minus 5x. Okay? Remember, this example, the goal was for us to get the goal, we missed some stuff in here, but the goal was to get the y's all to one side. So you see how we got y over here, y over here. I'm going to add this over to get at least the y's to this side. So I'll have just 5x on this side, with y plus yx on this side. Okay? Then, yeah, we missed this here. Then, when you factored out, we had yx minus y.
I know it's
We factored out a y and got y times x minus y. So here I want you to factor out y. So 5x equals. Focus. These are hard problems. I want you to be putting full 100% brain power trying this out. So 5x equals. Pull out a y. So erase the 4. In front, I want you to put y times in parentheses, and then I want you to see what's left in each term. So if you pulled out the y, you have 4 here plus x here. Now I've got y by itself, right? Like one of them. And since this is being multiplied, now you have the division.
I have a question, Miss.
Okay, erase this dividing by y. Because you're going to get a y stuck underneath of them. We got rid of our mark square, we don't want another one. What our goal is, this is great, except when you multiplied 5 minus y, you ended up just multiplying the x and y together. This is like a whole quantity. So you need to multiply your x times your y, and your x times your
because they changed it.
okay. Now, the goal is, remember like I'm doing right here, is to get all the y's on one side and the non-y's on the other side. So here, I want you to take this and add it over here to get like the y's together and the y's. So add xy over here, so that you have x instead of y on this side. You multiply the whole thing. You'll have to, you guys have to more steps. It's not there yet. You gotta multiply the whole Okay, you're gonna multiply the x and good. Now you can pull out a y. Pull out our y. See how we factored out a y. Pull out our y. Okay, now we want our y's together, right? We look back at this example. This y over so that we have x, y, and y.
Bro, I can still put the right here.
This is
Uno, como se mete dos por acá.
Cross the street, cross my street.
Yeah, because I go, is you were 70 minutes? I took a bus. So paso por la, I go Kirkwood, I just go Oxford. So I go to Rush. And I saw
show her where to go so I can keep asking them answering their questions. I'll be back. They've had their hands up for a long time. I'm not even here. Yes.
She's gross.
Sorry.
So I distributed X.
Okay. No, that's perfect. This is your wrong step when you divided by y. We want to avoid the fraction bar until the very end. We don't want to start dividing by y's again because then we're just going to get y's on top, y's on the bottom again. So let's go back to where you distributed. That's good. So x, 5x, yeah, we're good. The goal, remember, was to get all the y things on one side and all the x things on one side. So I'm going to add this xy over here. Come in so that I have 5x or x equals 4y, not times, right, plus. Okay, this now looks a lot more like your example went, but like this. Oh my God, we had two things with y and we factored out a y, right? So now factor out a y in front of this. Like you can pull the y out front and then write your parentheses and see what's left for each term.
Hey, no.
I'll be right back. Yes, but that doesn't mean right now we keep like trying and practicing, right? Because we won't have like all the time in the world to answer all your questions actually. So you can come and talk to me, but let's keep. Okay, yeah, that's fine. This is great. Distribute this now. Multiply x times both of them. Perfect. Now rewrite it as f inverse. Great. Here, no. Here, this is great, except we multiply this entire quantity. So you need parentheses, you need to distribute the x here now. Now this over here, where we subtract the y over. Okay, this one, subtract the y over to get all of the y's. And now this term over here, so we get the y terms together and this term over there. So add this term over here, and then let's see where we're at from there. Okay. Let's start by multiplying y minus y. Alright, I'm gonna bring it back because there's a lot of great questions. A lot of good questions around town. Where did my clicker go? There it is. Okay. Let's chit chat about this problem really quick. So really awesome things around knowing that. Don't expect to jump in and be able to do the whole thing, but it helps to be able to look at it yourself versus just writing down me talking through it. Because like then it sinks in a little bit deeper this time of what you have to do when you're on your own. So let's talk about this one. One more time, help me out. What time am I out of here? 42. Okay. So we'll finish with this one. Okay. Eyes up here. Yeah. Okay. When we have these and we multiply, first thing I noticed when people were multiplying, mistake to watch out for is they wrote like 5 minus y x and they multiplied the x times just the y, but this is a quantity that we're multiplying. So we end up needing to distribute the x to both, and we have 5x minus yx equals 4y. Okay? The goal, like the trick that you're going to continue to see over and over in these examples, is that remember we want to get our y terms together and the other ones separate so that we can factor out a y. Does this have a y in it? Does this have a y in it? Does this have a y in it? So these two things we want to be together. So I'm going to add over my yx and say 5x equals 4y plus yx. We good up to there? Okay. Both of these have y's. The reason I did that is because what can we do if they both have a y? We talked about this earlier. What can we do if they both have a y? I'm trying to, Catherine, I don't think you're following you. We can factor out a y. That means the first term has a 4 left, the second term has an x left. And now y is by itself. So last step, I owe Catherine stamp and stuff. So last step, Samantha, what do we do?
Divide by 4 plus x.
So we end up with f inverse of x equals 5x over 4 plus x. Okay? So again, if that's still like, what? The more you see these, the more this becomes a process that you are familiar with. And so we only have 2 minutes left, but I urge you to, the next one again is similar. We've got like a fraction bar again, but slightly different. So I encourage you to try this one as well as you like get better at this, and then try the ones on your problem set as we study for Monday. Okay? I'm gonna pick. Huh? No, that's just the blue from earlier. I just didn't erase it. All right, sing it. I don't have it up. Okay. 3, 2, 5. Come on down and get a cookie. Who are you? Javier, come on down. Next up, I've got.
Sure.
318. 318. Who are you? All right, come on down. Next up.
Thank you.
This y'all, the suspense. It's like it's killing me. 326. 326. Come on down. And the last one. 328. Have another day. Yes. I got at the beginning. And this is correct. Yeah, you were, but you had something subtraction like
This is so hard.
What? Here, you didn't distribute the X. Stay away from my feet, you didn't win. Here, and you're super close, but here you can see 3y minus 3x. Remember when you multiply this No, that's positive. Oh, to move it over to the other side? Yeah. Wait, did you eat your own?
I guess I bought one.
It's yours.
No, it's okay. I gave it.
Hello. Huh? Oh my gosh, they have all those binders there, so I don't know. Wait, I saw that there was a gold sticking out of it. Is that black one? No, the very top. No, like I said, by that folders or the other ones. I see a gold sticking out of it. Is that yours? There you go. Found it.
Me too.
Very scary. Very scary.
Stop bullying me.
Only when you're not the one sharing.
I think I'm sure.
Stop bullying me.